Hi guys, welcome to Algebra 1/2, Lesson 57. Today we're talking about ratios and proportions, as well as evaluating expressions with exponents and radical signs. So let's start with ratios. A ratio is a comparison of two numbers, which we often write as a fraction. For example, 3/4. I'm comparing 3 to 4. So I've written 3 over 4, 3/4. Fractions and ratios, they can have equivalent forms. So that means other fractions, other ratios that have the same value, they just have different numbers. So some equivalent fractions or ratios of 3/4 would be 6/8, 15 over 20, 90 over 120, and your book even has a couple of more, but you get the idea. Well, if I write this ratio, this fraction, next to an equivalent ratio, and I write it with an equal sign in the middle, just like this. 3/4 equals 6/8. I have created something called a proportion. So a proportion is a comparison of your two ratios, basically. Your proportion can either be true or it can be false. For example, here's the proportion of 1/2 equals 5/10. Does 1/2 really equal 5/10? Well, if I multiply 1 times 5, I get 5, and if I multiply 2 times 5, I get 10. So 5/10 and 1/2 are really the same thing. So this is a true proportion. Here I have 1/2 equals 7/10. Well, does 1/2 really equal 7/10? If I multiply 1 by 7, I get 7. But if I multiply 2 by 7, I get, only 10. So it's a false proportion. Now we're mainly going to be dealing with true proportions and how we solve when you have a variable in a proportion. So when you have a proportion like this, 20 over 15 equals 4 over x. This is a conditional proportion because you have a variable. So the whether or not this is true or false depends on what you put for your variable. So we can solve for this particular type of equation by noting one important fact. Let's look at this proportion right here. 3/4 equals 6/8. There's an interesting fact that if you cross multiply, so if I multiply like this bottom number with the top number, and this bottom number with this top number, I'm going to get the same number. 8 times 3 is 24. 4 times 6 is 24. So for every true proportion, when you cross multiply, you get the same number. Let's look at our other examples. 2 times 5 is 10. 10 times 1 is 10. It's true. Let's look at my false one. 2 times 7 is 14. 10 times 1 is 10. The numbers aren't equal, so it's false. And we already knew that it was false. Oops, sorry, trying to write my 10 and I'm struggling. Okay, and I already knew it was false. So based on this property, based on this rule that I can cross multiply and get the same number, I can use that to find my missing number. So here I have x right here. So I'm going to start by cross multiplying. So I'm going to multiply in the shape of an x. So I have x times 20, that becomes 20x, and it actually really doesn't matter which side of the equal sign you go on. And then I have 15 times 4, which is 60. Okay, now I have a really normal looking equation. I'm multiplying x by 20, I want to get x by itself, so I divide it by 20. Whatever I do to one side, I have to do to the other, so I divide 60 by 20. I'm left with x. 60 divided by 20 is 3. So that means x equals 3. And if I were to cross multiply, 3 times 20 is 60. 15 times 4 is 60. So I know I did it correctly. All right, let's try another one. 4 over 5 equals p over 7. Well, I'm going to start by cross multiplying. 7 times 4 is 28. 5 times p is 5p. I'm multiplying p times 5, so I need to divide by 5 to get p by itself. Like I said, it doesn't matter which side of the equal sign you end up on. So 28 divided by 5 can't reduce anything, so I'm just going to leave it like that. 28 over 5 equals 5 divided by 5 cancels, so I'm just left with p. So my answer is 28 fifths equals p. And even still, if I were to plug that 28 fifths in up here and cross multiply, I would get the same numbers, but I'm not going to do it for time's sake. Okay, one more thing that I want to point out to you in this lesson. We know how to solve exponential expressions, how to evaluate for a variable which is in an exponential expression or in a radical. But what if you're missing both of the numbers in your expression? So for example, here I have x to the y power. Well, as long as you know that both of those, you evaluate for both of those variables. So I have x to the y power where x equals 4 and y equals 3. I know that my base is 4, so I put 4 in place of x, and I put 3 in place of y. So I have 4 cubed equals, and then I just solve. 4 cubed is 64. Okay, what if I have radicals? I have the p root of q. Well, according to this, p is 3 and q is 64. So I'll draw my radical sign. P is 3, q is 64. So I'm looking for the cubed root of 64, which I know is 4. That's all you have to do. All right, go ahead and pause now. Do your practice on page 163. Okay, we are back. Letter A, you should have gotten 8 over 7 equals P because you multiplied 4 times 2 and 7 times P. Divide by 7, so you get 8 over 7 equals P. Letter B, you should have S equals 20 over 3 because you cross multiplied. 3S equals 5 times 4, which is 20. Divide by 3, so you get 20 over 3. Then letter C, x to the y power if x equals 4 and y equals 2. So when you evaluate, you have 4 squared. 4 times 4 is 16. And letter D, you have the x root of y. X equals 4 and y equals 16. So that was the 4th root of 16. And the answer to that is 2. Okay, that was it for today's lesson. Let me know if you have any questions. Finish up your problem set 57. See you later, guys. Bye.